Essentially, intrinsic motivation is closely tied to dopamine release in the brain. But unlike extrinsic motivation, it involves a more sustained activation of neural pathways, and particularly those that are associated with cognitive engagement, self-awareness, and the satisfaction of basic psychological needs. So if we just look at this in a bit more kind of detail, dopamine, which is the reward transmitter, associated with pleasure, with reward, it's released when we engage in intrinsically motivating activities. It's also released, though, when we're engaged with extrinsic rewards. However, the difference is if the motivation is coming from extrinsic motivation, rewards, that often just leads to kind of short bursts of dopamine. Whereas with intrinsic motivation, it's associated with a much more sustained and profound dopamine release. Again, important for that sustainability of motivation. Because it's that sustained release of dopamine that contributes to those feelings that we get of enjoyment, satisfaction, and engagement. Now, the key areas of the brain, as I'm sure you're all aware, is very, very complex. And it's not as easy as saying, well, this bit of the brain does this. All the brain regions or various brain regions work together. And the ones that are the kind of the key ones when it comes to motivation, I've actually put on the slide here. So the first one is our ventral tegmental area, VTA, which is part of the midbrain. And that area is absolutely crucial for the production of dopamine. We've then got our prefrontal cortex. Now, the prefrontal cortex is responsible for our higher order cognitive functions like decision-making, planning, and focus. But it's also activated during intrinsically motivated states. So this leads us to think then, suggests that intrinsic motivation is linked to increased cognitive engagement and persistence. Our anterior insular cortex, the AIC, this region is involved in self-awareness and salience detection and emotional processing. So research there suggests that the AIC plays a role in that experience of autonomy, which, as we'll talk about as we go through, is a key component of intrinsic motivation. Research shows us that for intrinsic motivation to be activated, 3 factors must be present. And those 3 factors are autonomy, competence, and relatedness. Intrinsic motivation is also associated with patterns of activity across these neural networks, as I've put there on screen. Large-scale neural networks involving many of the different kind of brain regions. So salience detection, so that's identifying what is personally meaningful and relevant. Our attentional control, so that's about sustaining focus and concentration. And our self-referential processing, so connecting the activities, the tasks that we're doing to our own values and identity. So we know from the science that intrinsic motivation is associated with when we see these patterns of activity across these large-scale neural networks. So we can actually, through MRI scans and etc., we can actually see when a person is intrinsically motivated with doing a task. So a deeper understanding of the neuroscience of intrinsic motivation can then inform our interventions and strategies to enhance motivation. So to conclude this little section then, neuroscience provides that really compelling evidence, and it's still a fairly new area of research for neuroscience, so I'm sure there's going to be lots more kind of coming out as we go forward. But there's that real compelling evidence that intrinsic motivation is rooted in those specific brain mechanisms and involves that really complex interplay of neurochemicals, and processors and neural networks. Applying that into the real world, it highlights that importance then of designing environments, workplaces, and activities, our tasks, our roles that really foster autonomy, competence, and relatedness to help us to tap into this powerful source of motivation.